So today we continue working on polygons. Today we're going to be talking about the interior angles of a polygon. So you got these notes in front of you that say investigation, interior angles of a polygon. So let's take a look at that. So I'm going to help you with the first two rows, and then I'm going to let you do the rest. I'll give you a little time limit, okay? But let's look at this. We want to name each of these. Now, if you already started, that's cool, okay? But this first shape, what do we call this three-sided polygon? What's it called? Triangle, right? So we got a triangle. Now, we look at the picture, okay, and then we go to the next one. Number of sides, number of angles. Now, just so you know, it's always going to be the same number of sides and angles. They match. It's going to be, obviously, 3, right? Now, this next column, what do we mean by triangles? Here's what we mean, okay? To make triangles, we're going to make diagonals. And to make diagonals, I'm going to show you on the next one what it looks like. But obviously, if it's one triangle, how many triangles are there? 1, okay? Okay. So the sum of the interior angles. Now let's remember, how many degrees are in a triangle? Okay, so a triangle has 180 degrees. So guess what? How many degrees are in one triangle? Obviously, 180 degrees, okay? So we took that 1 times 180, and we got 180, okay? Let's look at this next thing. Now, I know you might know what it specifically is, but what do we call any four-sided figure? Quadrilateral, okay? So, quadrilateral. Spilling over here. Now, on that third column, it says number of triangles, right? Here's how you make triangles. You are going to start at any vertex you want and draw all of the diagonals that you can. So let's pick this one. The only diagonal I can make on this goes from here to here. And now you can see how many triangles are there. So when you cut that rectangle, that quadrilateral in half, you get 2 triangles, right? So first of all, it's a 4-sided figure, but the number of triangles is 2. Okay? So think about this. If every triangle is 180 degrees, and there's 2 triangles inside of a quadrilateral, I'm going to do 2 times 180. So same thing, times 180. What is 2 times 180? 360, okay? How many of y'all saw some sick 360s on the Winter Olympics? Anybody watching that? Snowboard 360s? Whatever. All right, so you're going to do the rest of these. I'm going to help you on the picture part, okay? On this next one, whatever it's called, okay, put a point at one of your vertex corners and then draw all the diagonals. So that's it. Okay? So you're going to see a pattern. This one had 1 diagonal. This one has 2 diagonals. Guess what the next one's going to have? 3 diagonals. And then it's going to have 4 diagonals. You get the idea. So I want you to finish filling this out. On the very bottom, okay, you can try it, but if you get stuck, then make sure you're going from vertex to vertex. But if you get stuck on the very bottom one, we'll go over that together here. So I'm going to give you a couple minutes to try this on your own. Hello. There we go. Literally a couple minutes. So, all right, 2 minutes. See what you got. 3, 2, 1. Woo! Okay. Let's do this. First, I gotta see you later. Goodbye. I say goodbye. Oh my gosh. Whatever. Okay, let's do this. So this next shape is 5-sided. What do we call it? Pentagon. If you don't know these names, you got to get to know them. They're in your notes from the last 2 class periods. So, how many sides Pentagon has? 5 sides, right? Now, how many triangles did I create with those 2 diagonals? 3, right? So I got 3 triangles. And again, each triangle is 180. So 3 times 180 gives me 540. Okay. Next one. What's this called with 6 sides? Hexagon. Remember, 6 and hex have an X. All right. Now pick any vertex you want, okay, and make all your diagonals from that one vertex. So I'm going to have 3 diagonals, and 3 diagonals create 4 triangles, right? So remember, hexagon has 6 sides, but I've created 4 triangles. And then again, times 180. So what do we get? 720. Now, hopefully by now you see a pattern showing up. This next one that has 1, 2, 3, 4, 5, 6, 7 sides, what do we call that? Heptagon. Okay? So hex is 6, hept is 7. Okay? And again, pick a vertex, draw all of your diagonals to that one vertex. Don't forget this one down here. It is a triangle. So I had 4 diagonals, which makes 5 triangles, and I'm going to write that right here. And again, to get my degrees, 5 times 180 gives me what? 900. All right. Next one. So again, 1, 2, 3, 4, 5, 6, 7, 8 sided is an octagon. Okay. Step into the octagon. Now, pick a vertex. Draw all of your diagonals, including this one down here. 5 diagonals gives me 6 triangles. And again, 6 times 180 is 1080. Now, when I was younger than y'all's age, when the Nintendo 64 was new, there was a game called 1080. And it was snowboarding. And it was lit. Alright? So look it up. 1080. Woo! Now, polygons with n side. Now, we're making a rule at the bottom. Okay, what's the rule when we're talking about how many degrees are inside of a polygon? Okay, so notice at the end of every one of these rows, these numbers are not the same, right? They keep changing each time. But we can get a rule or a formula to help us figure out. If we know the number of sides, then we can figure out the number of degrees inside. So again, look at the top of this notes page. It's called interior angles of a polygon. We are finding how many degrees are inside. Okay, I hope you know a triangle is 180. But you got to know how to figure out a quadrilateral, a pentagon, hexagon, heptagon, and octagon, right? So let's make a rule at the bottom of this page. Okay, so let's say I have an n-sided figure. So remember, this right here is how many sides. So if it has n sides, what am I going to put right here? N, because I just told you it's n sides. N just means some number, any number, whatever it is, we put n there, okay? Now, think. Okay, you're going to have to use your thinking caps. What do you notice between this row and this row? What's the difference? Okay, 2, right? Does everyone see? Like all the way up and down. At the very top I had 3 sides, 1 triangle. 4 sides, 2 triangles. 5 sides, 3 triangles. 6, 4, 7, 5. You see the pattern. The number of sides minus 2 is how many triangles you have. Okay? So if n is my number of sides, and I'm subtracting 2, and subtracting 2, what should I write? n minus 2, okay? Whatever n is, subtract 2. Okay? So again, to figure out the number of triangles, I subtract 2 from n sides. Now, how did I get from this column to this column? Hint, I drew it on every single one. What do you see right here? I multiplied whatever was here times 180. So guess what I'm going to do? I'm going to take this times 180. All right? So we're going to use some parentheses for the n minus 2. So n minus 2 times 180. N minus 2 times 180. That's going to be our formula. From now on, if you have a polygon and you're looking for the angle degrees inside of that polygon, take the number of sides minus 2 and multiply that by 180. And that'll get you the sum of the interior angles. Okay? So we're going to kind of formulate that on the back, so you can flip that over, please. The back side where it says like this. In the space below, write a conjecture about the sum of the interior angles of a polygon with n sides. Okay? So we're going to actually split this in half. Okay, polygon sum. Okay, I want you to kind of extra underline. We're talking about the sum, the total, adding them all up. Okay, so this is a total interior angles. Okay, the total interior. So we are going to write that same formula that you could write in a sentence. You could say the number of sides minus 2 times 180 gives you the sum of the interior angles. But we're just going to write the formula, okay? So parentheses, n minus 2 times 180, okay? We're going to fill in the right side of that in a minute, okay? Because for now, we're just finding the total. But what if I want you to find one of them? We'll get to that in a minute, okay? But let's reflect in the reflection questions. What is the measure of the sum of the interior angles of each of the following polygons? So, sum interior. That's exactly what we're doing up here. Sum interior, right? So let's do that. All I got to do is take a 35 gon. How many sides is a 35 gon? 35. All right, easy, right? So take that number 35 and plug it into n. Replace n with the number 35, type it in your calculator, and get your answer, right? So I'm going to write 35 minus 2 times 180. Does everyone see what I'm doing? That formula with that number, get your answer for the sum of the interior angles. So what is 35 minus 2 times 180? Okay, so I know someone's got it right here. 35 minus 2 times 180. We get 5,940 degrees. All right, cool. Now we got to think about this because we got to know these vocabulary words, right? We got to know 3 through 12 for polygons. So dodecagon, okay? We ain't talking about no Pokemon, no Dodrio, no Doduo, right? But we're talking about dodecagon. Remember, I like to use Spanish to help me. Dodecagon reminds me of dos decagon. You take the decagon plus dos, 10 plus 2, you get 12, right? So a dodecagon. This means n is equal to 12, okay? Up here, n was equal to 35, right? But when n equals 12, all I'm going to do is do the same exact formula, right? 12 minus 2 times 180, okay? And again, you can type it in your calculator into one step. Parentheses, 12 minus 2. Now, you could do 12 minus 2 in your brain. You could do anything minus 2 in your brain, I hope, and then multiply by 180, okay? You could have said, I know 12 minus 2. That's 10 times 180. Either way, you're going to get the same answer, 1800, right? My favorite decade and millennium and century and all that. So, 1800. So, 125 gon. I hope we all know how many sides are on a 125 gon, because it's in the name. 125, right? So n equals 125. So that means 125 minus 2 times 180. Parentheses, 125 minus 2 in the parentheses times 180. So I get 22,140. All right? So any questions on how to do that? If you see the phrase sum interior, then you know what you're going to do. N minus 2 times 180. Okay? I'll give you those formulas in the future. You just got to know what to do. Now I'm not moving it all the way away. Let's put it right there. So look at number 2. Okay? Ignore this business over here. Okay? So the figure below is a regular decagon. Now let's remember, what does regular mean for polygons? Okay, so the sides are congruent. They're all the same. Their measurements are equal. Okay? So remember, regular means all the sides are congruent, and in the angles, all the angles are congruent. Everything's the same in a regular polygon. So that means, you know, if I were to label this, and I'm going to count these sides just so I make sure it's a decagon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. All those sides are the same. And guess what? All these angles are the same. Now, do you have to label this every time? If it just says the word regular, then you know this is all true. Okay? So all the sides are the same. All the angles are the same. So what do we know about the side lengths of the regular decagon? They're congruent. You can put the word same, but congruent's the best math word for that. Letter B, what do you know about the angle measures of a regular decagon? Well, again, we know they're congruent. And then letter C, what is the measure of each interior angle? Now, each means we're not just trying to find the sum. Okay? Now, we're going to have to find the sum, but once we find that sum, we need to make it break down into 10 equal parts so I can find each. So this is a very important key word here. So what I'm going to do is I'm going to take that decagon, and I'm going to find the sum, and I'm going to use that formula we just used, n minus 2 times 180. So I'm going to do 10 minus 2 times 180. But once I get that, that's the total. What do I do to get each? Okay, I heard it over here. We're going to divide by what? The number of sides, which is 10. So I'm going to divide this by 10. So I want everyone to pause for a second and look right here. Okay, when it says the word each, you have one extra step where you have to divide by the number of sides. Okay, now pause on letter C. We're going to go back up to the top, and we're going to write a formula for each. Okay, each interior angle of a regular polygon. Okay. So if we need a formula to find each interior angle of a regular polygon, it's going to be the same formula, n minus 2 times 180, but we're going to divide by the number of sides, which is n. Okay? So here's another formula we need to know today. If you see the word each, okay, I'm going to make it blue. Each, then you're going to use this formula. If you see the word sum, then you're going to use this formula. Okay? Do you see the difference? Sum is all of it together. Each is just one. Okay? So sum versus each. The big difference is dividing by the number of sides. So let's go back to where we were at on letter C. So I need to plug this in my calculator. 10 minus 2 times 180 divided by 10. So 10, sorry, back up. 10 minus 2 times 180 and then divided by 10, okay? 144. She did. Very good. Proud. Cooking. All right, so 144. We're sizzling. We're in the skillet sizzling. So that means all 10 angles are going to be 144 degrees, and they're going to add up to 1,440 sum total, okay? Now, we're going to use that on number 3. What is the measure of each keyword interior angle of a 25 So, just like letter C up here, let's do number 3 down here. So 25 so 25 minus 2 times 180, and then what do we do with it? Divided by what? 25. Okay. 25 minus 2 times 180, and then divided by 25. Now, if you get something like this, press Control Enter, 165.6. Because we do need a decimal for angle degrees. All right, and then last but not least, on number 4. Now, this is kind of like a challenge. It's a 5-sided figure, right? 1, 2, 3, 4, 5. So I know 4 angles, but I don't know the 5th angle. Now, before I can figure out the 5th angle, I need to know what did they add up to. So what I need to find out is the sum. If I can find the sum of a 5-sided figure, then I can figure out the missing. Okay? So now, if you flipped it over, we already did this, but we're going to pretend like we're just doing this fresh. So how many degrees are interior sum of a 5-sided figure? We have to use this formula. N minus 2 times 180. First you do this. Okay? What is 5 minus 2 times 180? I'm going to cheat and go back to the front side of my... Okay? So we did this right here. Okay? 5 minus 2, so 3 times 180, we got 540. So for a pentagon, down here, it has to add up to 540. This is going to be kind of like in the past where we had a triangle and we knew 2 angles and we were missing an angle. Do you remember what we did? We added up all the ones we knew and subtracted it from the total. So in this case, we're going to add up 81 plus 108 plus 135 plus 81. And when we add those up, we're going to subtract that from 540. Okay? Not 180, 540. All right, so let's do that. What is 81 plus 108 plus 135? Let's show my work here. Plus 108 plus 135 plus 81 again. And what do we get? 405. 405. All right. So now I got my added up angles. I got my total, 540. And all I do is subtract those two. So 540 minus 405 gives me what? 135 degrees is going to be my missing angle. Do you see how we had a couple steps on that one? Okay. So that's what you're going to be doing on the assignment today. Not necessarily like the last one, but make sure you read the instructions carefully. The front side says sum, n minus 2 times 180. The back side says 1 interior angle, okay? So when it says 1 interior angle on the back, I want you to write each, okay? That's the each. Let's make sure we add that to our notes real quick, up here at the top. Everyone stay with me. I want you to write the word 1. If you see the word 1 interior angle, that means each interior angle, okay? So when you get to the back side of the assignment, you're not doing the sum, you're doing the each. You're doing the 1, okay? You're doing the second formula we learned today because you're finding just 1, okay? So I think you'll be able to knock these out pretty quickly. You'll get the hang of it. It'll be good. All right. So take the pass. All right. So use your notes to do this assignment. If you don't finish today, I think you'll be able to do it for homework.